An aromatic hydrocarbon, of which the molecular structure incorporates one or more planar sets of 6 carbon atoms that are connected by delocalized electrons numbering the same as if they consisted of alternating single and double covalent bond. Aromatic hydrocarbons can be monocyclic or polycyclic. Some non-benzene based compounds are called heteroarenes, which follows Huckel rule, are also aromatic compounds. In these compounds, at least carbon atom is replaced by one of the heteroatom, oxygen, nitrogen or sulfur. For example, benzene, toluene, naphthalene and biphenyl. Example of heteroarenes is pyridine and thiopene. Benzene ring is highly unsaturated, but in a majority reactions of aromatic compounds, the unsaturation of benzene ring is retained. Aromatic compounds containing benzene ring are known as benzenoids, and those not containing a benzene ring are known as non-benzenoids. Structure of benzene. The Kekulé structure indicates the possibility of two isomers. Kekulé structure of benzene fails to explain unusual stability and preference to substitution reactions than addition reaction. You can here see the bond length of planar hexagon bond, that is 140 picometer, and bond angle equal to 120 degree. Let us now study about resonance. Benzene is a hybrid of various resonating structures. The unhybridized p orbital of carbon atom are close enough to form a pi bond by lateral overlap. There are two equal possibilities of forming 3 pi bonds by overlap of p orbitals of C1C2, C3C4, C5C6 or C2C3, C4C5 and C6C1 respectively. The The delocalized pi electron cloud is attracted more strongly by the nuclei of the carbon atoms than the electron cloud localized between two carbon atoms. Therefore, presence of delocalized pi electrons in benzene makes it more stable than the hypothetical cyclohexatriene. Benzene is a planar molecule. You can see here the planar structure of benzene. The absence of pure double bond in benzene accounts for the reluctance of benzene to show addition reactions under normal conditions, thus explaining the unusual behavior of benzene. An aromatic compound contains a set of covalently bound atoms with specific characteristics. A delocalized conjugated pi system, most commonly an arrangement of alternating single and double bonds, coplanar structure with all the contributing atoms in the same plane. Contributing atoms arranged in one or more rings. A number of pi delocalized electrons that is even, that is 4n plus 2 number of pi electrons, where n equals to 0, 1, 2, 3 and so on. This is known as Huckel rule. For example, benzene and cyclopentadienyl anion, where n equals to 1, that is 6 pi electrons, and also cyclopentadienyl cation, and also naphthalene, where n equals to 2, that is 10 pi electrons, and so on. Planar monocyclic molecules containing 4n pi electrons are called anti-aromatic and are in general destabilized. Molecules that could be anti-aromatic will tend to alter their electronic or conformational structure to avoid this situation, thereby becoming non-aromatic.